This is introducing the concept of linear systems. And more specifically, we're going to solve linear systems through something called substitution. First of all, I want to talk about what a linear system is. A linear system is anytime you have a Cartesian coordinate plane and you have two lines taking place. So you might have one, say, here, and one, say, here, or wherever. And the key is that those lines are going to intersect unless the one condition where they don't is if they are parallel. But aside from being parallel, if there are two lines on a graph, they're going to intersect at some point. So if we were given the equation for two different lines, we could, if we wanted to, graph them and then look for where they intersect. But I want to actually solve this problem algebraically. And we're going to do it with a technique that's known as substitution. So let's say we were given this information, that there are two lines on a given Cartesian coordinate plane. We would like to know where those lines intersect, and we're given the equations of their lines, and that's all we have. What I want to do is I want you to notice that in the first equation, this y right here is all by itself, and it's equal to x plus 2. Well, what if I went to the y in this equation and just replace it with what y is equal to, the x plus 2 part? So in other words, if I rewrote this second equation, x plus 2 plus x equals 8. Notice that I've just basically changed this y into x plus 2. And then I could combine like terms. So 2x is equal to 6, and x must be 3. So I just found the x-coordinate of where these two lines must meet. If I want to find the y-coordinate, I can substitute that 3 in for x into either one of these equations and solve, and you'll find it. So for example, the first equation was y equals x plus 2. If I go back and plug in 3 for x, I wind up getting 5 for y. So the intersection point for those two lines is 3, 5. Unless the lines are parallel, they're going to intersect somewhere. Let's try again. It takes a few times to practice this to get to where you're comfortable with it. Now this second example is different than the first example in that notice that neither equation has a variable isolated by itself equal to something else. But that's okay, we can work around that. Look at this equation, the x plus y equals 15. Well, what if we just subtracted a y from both sides? Then we would have x is 15 minus y. So now we've got a variable by itself. We can substitute in the second equation what it is equal to. So now I'm going to rewrite that second equation 4 times, and instead of putting x, I'm going to put 15 minus y. Carry out the rest of the problem. I've got to distribute. Subtract 6. Well, let me combine like terms on the same side. If I subtract 60 from both sides, it is negative 22, so y must be positive 22. So I know the y-coordinate of where they intersect. To find the x-coordinate, I can plug back into either one of these equations. I'm going to go with the first equation because it doesn't have, the coefficients are smaller. It's going to be easier to work with. But the idea is that now we're going to rewrite that x plus, instead of y, I'm going to write 22 because we know it equals 22. Subtract from both sides, and x must be negative 7. So your answer is always in the form of an ordered pair coordinate of where those two lines are intersecting. I have 2 more and then we'll be done. First one, d equals 4c, c plus d equals 20. Obviously these aren't in standard form or slope-intercept form, but 2 variables in a single equation means you've got the equation of a line. So I think I could just go ahead and substitute directly for d into the second equation. So instead of d, I'm going to write 4c equals 20. So 5c is 20, c must be 4. Well, if c is 4, d must be 16. So I intersection point 4, 16. When you deal with variables that aren't x and y, like c and d for example, always put the first one that comes in alphabetical order as the x term, and then the other one is the y term. Last one. 3n plus 5m equals 7, m minus 4n equals 6. So we're obviously going to have to put our answer in the form of m then n. So I'm going to have to isolate n or m in one of the equations. I'm going to choose to use this one because its coefficient is already 1, so I'm only one step away from getting it by itself. And then I have to go back and replace the m in the first equation with what it's equal to. 4n plus 6 equals 7. So 3n plus 20n plus 30 equals 7. Combine like terms. 23n equals negative 23. n equals negative 1. And I'm going to replace this guy into here to find my m term. So m minus 4 times negative 1 equals 6. M plus 4 equals 6. M must be 2. So my final answer is 2, negative 1. Alright.